So as always, let's take a few minutes to review everything that we learned in this section of the course. In this section, we focused on React class components, and we can call this the more legacy way of defining React components. It's certainly the more older way because this was the only way that we could have stateful components in React when the library was first introduced. Now, the React team has no current plans as of 2022 to deprecate or remove class components, and that's likely due to the fact that they're still in wide use in many code bases around the world. So there's no plan to remove this way of building components. But with that said, if you're working in a more modern React code base or building something from scratch, you're probably going to be using functional components. With that said, it's still important to understand this class-based syntax because you're still going to find plenty of examples of it in React code bases. So how does it work? Well, we begin by defining a ES6 class, a regular JavaScript class, and using the extends keyword, we make it inherit from the component superclass from the React library. And that is what allows our regular ES6 class to become an actual component class and have access to special methods such as setState. The only requirement within our class body is that we must define a render method, and that render method will specify the JSX that component will represent. It's the exact same idea as in our functional components where we return JSX at the end of the function. It's just the visual element or the visual piece of that component whenever it is rendered onto the screen. Concepts from functional components carry over with occasional differences to class-based components. So the rendering syntax is still the same. We can have an opening component tag and a closing component tag. We can have a self-closing component. We use curly braces in the JSX in order to evaluate a dynamic JavaScript expression. Concepts like props carry over, but they are a little bit different. So for example, in our class component, we reference props using this.props, while in functional components, props from the parent are available as the first parameter to that function. So there are some differences as far as syntax, but the core mechanics of components remain the same. They're just a reusable chunk of the user interface that we can render as many times as we want, that we can pass props into, etc. So the next thing we focused on was component state, which is a very key feature of components in React. So state is simply data that's going to change over time, usually data that's going to change over the course of the component's existence. If the component will have state, and it doesn't have to, but if it will, we declare the state in the constructor method of our class definition. Now we assign initial state in the constructor using the this.state syntax. Now earlier on, I told you that the state could be anything, and I was actually mistaken. The state in a component must be either an object or null, and 99% of the time, it's going to be a regular JavaScript object. And the reason it's going to be an object is because that is the only data type that can support multiple properties, right? Multiple things being set. Because our component may have many different pieces of state to worry about, and they may not necessarily be related to each other. They may be independent. So maybe you'll have three properties, let's call them A, B, and C, and they'll be responsible for one bit of the JSX and one bit of what is rendered in the component. And then you may have D and E as two other component state properties, and they may be responsible for something totally different in the JSX. And the only data type that can store those different properties together and find an elegant way to update them over time is an object. So typically this.state will be an object, and you can choose whatever properties you want to give to that state and also provide them with their initial values, their initialization values, all right? Now, if you're using state and you're declaring it with this.state, it's very important that at the top of your constructor method, you make sure to call super and pass in props. And you're going to receive props as the first argument to your constructor method. The reason the syntax is critical is because it runs the superclass constructor in the superclass. That is the component class that you are inheriting from. And that is what allows React to initialize key component functionality such as this.props. So when we define a constructor, we override the one that we get from the parent, but we still want to run the parent one, and we do that with the super prop syntax. And so if you're going to be defining state, you must do so in a constructor, and if you're going to do that, you must remember to call super props. And once you get used to the pattern, it obviously becomes kind of second nature, but a lot of beginners forget to do that super prop syntax, so it's very important to memorize that. All right, so in the constructor, we set the initial state with this.state, and as I mentioned, that is the only time that you should write to this.state. You can certainly reference this.state anywhere in any of your components instance methods, such as render, if you want to read a property from the state, but the next time you want to write to the state or update it after the constructor, you must do so with the setState method. That is the proper way, because that is the only way that forces React to re-render the component. When the state changes, React will rerun the render method. It's going to get the latest batch of JSX with all of the dynamic values of your state populated throughout, no matter what that state is doing. You're going to have kind of the next iteration of the component's JSX, and then React is going to write it to the DOM, to the screen. So the setState method accepts a JavaScript object with the state properties that you want to update in the next draft or iteration or version of the state. Keep in mind, you only need to provide the state properties that you want to update. You do not need to provide the next version of the state. And the reason that I bring that up is because different libraries within the React ecosystem have different paradigms as far as how they want to get to the next state. Some libraries will say, we want the complete next object that you want to be the next state. In React, it doesn't work that way. In React just cares about what properties you want to update right then and there. The other properties will stay the same. So for example, if you have 5 state properties declared in this.state, and you only want to update 1 out of 5 of them, then you just provide that one property name in your setState object, and it will update that one property, and the other 4 will be preserved as is. So you're not accidentally going to override your original state with your new object. Rather, your setState object is just the limited set of properties that you want to update along with their new value that you want React to write. And once again, whenever you call setState, that will trigger a component re-render. The next thing we talked about is event handlers, and that is simply a function or method that React will execute whenever an event occurs. And most events are going to be user-driven, such as clicking or typing, but some events may be related to the browsers, for example, an image failing to load. As we saw when I scrolled down that React documentation page, there's dozens of different events that we can react to. We can even react to the user, for example, copying and pasting from our app. And the way this typically works is we target a JSX element, and then we provide the prop attribute syntax, which is the on keyword followed by the event. So for example, for a click, there is an on click event. And again, on the React documentation, you can see a list of all of those possible events that we can react to. On click is for a click. And then we assign it either a function or a method. So we saw first that we can pass a regular arrow function in line, and that worked fine. But generally, it's a good idea to separate our JSX from the methods, because that kind of decouples the HTML from the JavaScript. They're different responsibilities, and it can be kind of jarring to see a bunch of JSX and then, a 5-line method that relates to JavaScript in the middle of that. So probably the most common approach is seeing developers extract that logic to helper methods that are defined in the class component body. Now, when passing a method to an event handler like onClick, remember that the this keyword may not be correctly set in the component instance. It may not be the component instance, the actual component object that has methods like setState. And we saw a couple solutions to deal with this, such as the bind solution, where in the constructor we access the actual method and we bind the this keyword to be the correct value, which is the actual component object. But the most common solution you're going to see today that is made possible due to Babel and the transpiler is to use the class property syntax. That's where we write our method name, then an equal sign, and then use the regular arrow function syntax. And that will allow the this keyword to always be correctly set to the component instance, to the actual component object, to the object that has inherited all those correct methods from the React component superclass. All right, we also learned about the synthetic event object. So whenever an event occurs, React will generate the synthetic event object, and it will normalize its properties so that it can work in every browser. The browser itself, by the way, generates its own event object, and React takes that and normalizes those properties to ensure that regardless of what browser the event occurs in, the final synthetic event object that you end up with will always be the same, and thus your code will work no matter what browser you are in. So React hides away the differences of the browsers from you, and that's another benefit that it gives you as a library. So when that event occurs, React is going to capture all that information and metadata in that regular JavaScript object, and it's going to pass that event object as the first argument to our event handler. It doesn't matter whether our event handler is a function or a method in line. React is going to utilize the same procedure we give it, whatever procedure we give it, and give it that event object. And it's up to choose whether we want to utilize any of those properties or metadata on that event object. Sometimes we care about them, sometimes we don't, but we always have access to that event object in case we need it. Finally, the last thing we saw is component libraries. So we can utilize components from other developers and libraries. Something like a switch or a toggle component actually requires a lot of web developer knowledge to build. There's a lot of HTML and CSS that is involved with making it look pretty and accessible. So when it came to us, I said, why not just get a toggle from another library? And we utilized React Switch. And we saw that the rendering syntax was exactly the same. We imported the switch component and we used the self-closing syntax of writing the component name, then a slash alongside the opening and closing brackets. And we successfully rendered the switch component onto the screen. And then we can also customize the component usually with props, but those are going to be defined by the developers who built it. So the component props that we saw on Switch may be totally different from the props that we would have gotten if we'd used another Switch component from another library or collection of components. So you have to do a little bit more research with whatever you're working with to see what it supports. But afterwards, the challenge we had was connecting the switch component with our component state and making it so that rather than following the switch component's traditional on-off design, we kind of manipulated that slightly to make it a toggle simply between different versions of our user form, either a registration mode or a login mode. And we found a way to connect that component and its props to our state. All right, and again, those solutions can be creative and they can range depending on what component you're using and how you're integrating it with your state, which is also going to be something that you ultimately decide in your project. We saw how we began with a piece of state that was a simple text property because that was all we needed for all the dynamic differences in our component. And then as we saw that there were going to be multiple differences, such as a toggle that had different modes, such as a welcome text, and such as a button text, we saw that keeping all of that in a single text property is probably not scalable, so we moved to a login mode state property. So those kinds of aspects of how do you define your state, what properties should it have, how do you deal with derived data, right? And the answer to that, by the way, is you usually deal with it in the render method by calculating it before the return JSX. But those kinds of questions are more design pattern questions in React that you get better at the more you practice with building these components, building them to be small, reusable, independent chunks of the user interface. All these common themes that we have discussed throughout the course. But I hope you had fun learning about state in React, and we're going to continue learning even more about state in the next section as we continue building out our user form and building things like the inputs the user will fill in order to register or log into our site. So lots of fun up ahead. Hope you enjoyed this section, and I will see you in the next one.